All right, let's get right into it. The world of AI is moving at an absolutely incredible pace, but it's been quietly running up against this massive invisible wall. Today, we're talking about a huge breakthrough from NVIDIA that might just be the sledgehammer we need to smash right through it. It's a whole new way to train the most powerful AI models faster and way more efficiently than ever before.
First, I just want you to look at this number, 10 trillion. Just let that sink in for a second. In the world of AI, what could that possibly represent? That's it. 10 trillion little pieces of data or tokens, that's what it takes to train just one of today's top-tier AI models. And you can imagine that colossal scale is creating a serious bottleneck. It's slowing down the entire field.
And that right there brings us to what everyone in the industry is calling the AI scaling problem. We all want to build bigger, smarter, more capable AI, but the resources needed to do that are just getting astronomical.
We're talking about a mind-boggling amount of compute power. We have to measure it in yottaflops. That's a quadrillion calculations every single second. It's a huge investment of time, energy, and, of course, money. We're hitting a wall where just throwing more computers at the problem, well, it's just not going to cut it anymore.
So that leads us to the critical question, right? How do we get smarter about this? How can we make the whole training process way more efficient without making the models any less powerful? That is the billion-dollar question. Well, the industry has been kicking around a potential solution for a while now, but it's a tricky one. It comes with this incredible promise on one hand, but some serious danger on the other. And it all revolves around 4-bit computing.
The basic idea is actually pretty simple. Think of it like using fewer decimal places in a math problem. The industry already got huge speed boosts by moving from 16-bit numbers down to 8-bit. So you'd think the next logical step is obvious, right? Let's just cut it in half again and go down to 4-bit.
But here's the catch, the big trade-off. On one side, you've got 8-bit precision, or FP8. It's accurate, the training is stable, but man, is it slow and expensive. On the other side, you have 4-bit, or FP4. It's super fast, super efficient, but historically, it's been dangerously unstable. We're talking training runs that just completely fall apart and collapse.
And this is exactly where NVIDIA's new research comes in. They didn't just find one little trick. They came up with an entire breakthrough recipe that finally seems to have tamed 4-bit training for good.
The first ingredient is a brand new data format they call NVFP4. Now, this is not your standard 4-bit format. It's way smarter. It uses a more precise scaling method that helps it capture the most important information in the data, even with such limited precision.
But here's the thing. Even this really clever new format isn't the whole story. To actually make it work when you're training a massive AI model, you need a very specific set of techniques to keep the whole process from going off the rails.
And this is that 4-part recipe. First, they're strategic. They keep the most sensitive parts of the AI's brain in higher precision, kind of like protecting a fragile core. Second, they use a clever math trick to handle any crazy data points. Third, they apply special scaling to the model's weights. The knobs that tune its knowledge. And finally, they use a special kind of rounding for the learning signals to keep everything on track. Every single piece here is crucial.
Okay, that second step, random Hadamard transforms, sounds super complicated, right? But what it does is actually pretty cool. See, any big data set has outliers, these extreme values that are really hard to represent with just 4 bits. This technique basically takes those spiky, extreme values and kind of spreads their energy out, making them much easier for the 4-bit format to handle without messing everything up.
So, we've got the format and we've got the recipe. It all sounds great in theory, but does it actually work in the real world? Well, NVIDIA decided to put it through the ultimate test. And they really did not hold back. They took a huge 12 billion parameter model and trained it on that insane 10 trillion token dataset. They put their new 4-bit method head-to-head against a stable 8-bit version. The goal was simple. Could the 4-bit model actually perform just as well? The results were, frankly, remarkable. As the researchers put it in their paper, the 4-bit NVFP4 model learned just as well as the 8-bit one. It tracked it almost perfectly across the entire massive training run. The performance was, for all intents and purposes, identical.
And to make that a little more concrete, just look at the accuracy on a really tough reasoning test. Look how close those bars are. The 8-bit model got 62.62%, and the 4-bit model was right behind it at 62.58. That difference is completely insignificant.
They achieve the same level of intelligence with half the precision.
So, the conclusion here is just undeniable. With the right recipe, 4-bit training isn't some risky compromise anymore. It's just as stable and just as accurate as 8-bit training, even at a totally massive scale.
Okay, so this is all very cool from a technical standpoint. But what does this breakthrough actually mean for the future of AI?
Well, it completely changes the game for what we call AI factories, those huge data centers that build these models. By using 4-bit precision, they can get way more efficient, pushing a lot more data through the exact same hardware they already have.
And the implications of that are huge. We're talking faster training cycles, which lets researchers experiment more, try out new ideas, and build things like specialized models for science or medicine. It creates a quicker, more affordable path to the next generation of AI, and really importantly, it makes the whole endeavor a lot more sustainable and energy efficient.
I think this quote from NVIDIA's own technical blog really just sums it up perfectly. This isn't just about saving some money. It's about expanding the very frontier of what is even possible with artificial intelligence.
This really is a foundational shift in how AI gets built. So I'll leave you with this to think about. With the floodgates of training efficiency now thrown wide open, what incredible new AI capabilities, maybe things we haven't even imagined yet, are going to get unlocked first?